this question, these two transistors are connected in series and they are ideal, right? So we get that the GM for the two individual transistors is dou ID by dou VGS. This is by the definition of transconductance of a transistor, right? But both the transistors are in saturation, right? So therefore they are in series and they have the same value of ID, the ID in this numerator, right? And we ignore channel length modulation for DC analysis for obtaining GM, right? So because they are in series, we now get the expression of ID as mu n Cox by 2 W by L VGS minus VTH the whole square, right? Taking the derivative with respect to VGS, this 2 will come out, this 2 will come out, and it will cancel with that. So therefore we get this as the expression for GM. In terms of ID, that is in terms of the original ID, we will get it as square root over 2 mu n Cox W by L times ID, right? And from this expression we can say that because the two transistors have the same drain current, right, and are identical, which is to say that they have the same mu n Cox W by L, by this formula they will also have the same GM. So the idea is that GM1 is equal to GM2, right? So now let's proceed with the small signal analysis. We know that for a transistor having GM and R0, the small signal equivalent, let's say for an NMOS with GM and R0, the small signal equivalent is a control current source whose current flowing in that direction is GM times VGS with a R0 connected between drain and source, right? So therefore the current ID can be given as ID is equal to by so if you see the current ID flowing through the M1 transistor, it will be GM VGS times M1 plus VDS of M1 divided by R0, right? Because it's the sum of these two branch currents, one branch current going into R0 and the other going to GM VGS, right? So ID will be VDS M1 by R01 plus GM VGS M1. Similarly for M2, you will find that it's VDS M2 by R02 plus GM VGS M2. But from this circuit we can see the following facts, which is that Vs M1 is equal to 0 and Vg, because this is small signal, we null all DC sources, which is to say that an input bias DC bias voltage gets nulled, which is that it becomes 0. So Vg M2 is equal to 0 and Vd M1, which is that terminal, is the drain of M1, is Vs M2, which is also the source of M2. And remember, since we are finding the output resistance R0, we will also ground the input voltage at the gate, so that is also grounded, which is to say that Vg M1 is also equal to 0, right? And we are calling this voltage as Vd. So what we get in these expressions is that Vd M1 is just equal to Vd, the drain of the circuit, and Vg M1 and M2 are both equal to 0. Vs M1 is equal to 0 and Vd M2 is equal to Vd M1 is equal to Vs M2, right? So from the circuit we get the following facts. Now let us substitute them in our expressions to get what we want. the expression for the output resistance. So first in this expression, if you'll see that Vg and Vs of M1 are both 0, so therefore this just goes away, and again since Vs M1 is 0, that goes away. So ID is simply Vd M1, which is Vs M2, right? So we get an expression for Vs M2 is equal to ID times R0, right? Then in the second expression we will find that in the second expression we can just substitute Vs M2 here, right? And since Vg M2 is 0, this will simply be minus Gm Vs M2, and Vs M2 is ID R0, so this is minus Gm times ID times R0, right? So we get that ID is equal to ID is equal to Vd minus, so this Vs M2 comes here as ID R0 divided by RO2, and this expression just becomes this, so that is minus Gm ID R0, right? So that is what I have over here, and you can pause the screen at this point to see how I bring about just the fraction Vd by Id, which is the small signal Vd, which if you go back to the original circuit, you will find that this is the dou Vds by dou Id that was asked in the question, and you will see that it reduces to the following expression, right? So since Gm is pretty large, we can, and since Gm is pretty large and Gm RO1 will be even larger, we can ignore the RO1 plus RO2 with respect to Gm RO1 RO2. So therefore we get that it is approximately equal to Gm RO1 RO2, right? So the correct answer is C.